Hi guys, my name is Beyza Nurselvi and today I will be explaining my Java homework. So let's start. I'm gonna talk about what I tried to do with this code. So first, well, this line imports the linked list class from Java util package. We'll be using linked list as the underlying data structure for our DQ implementation. Here, I will I define a generic class named deco parameterized by type T, which allows us to create a deco that can hold elements of any type. And for here, this line declares a private instance variable deco of type linked list T, which will be used to store elements in our deco. And here, this is the constructor of deco class. It initializes the deco variable by creating a new instance of linked list. And now we're to operations. This method, public enq t item deco add last item. This method adds an element to the end of the deco, mimicking the enq operation in the queue. For here, this method removes and returns the first elements from the deco, mimicking the deco operation in queue. If the deco is empty, it throws an illegal state exception, which says deco is empty. And for here, it's a method that adds an element to the front of the deco. It's mimicking the push operation in a stack. And for here, removes and returns the first elements from the deco, mimicking the pop operation in a stack. If the deco is empty, it throws an illegal state exception, I said. Public is empty, and now I'm here. Yeah, this method checks if the deco is empty, and what did I try to do here? It's actually the deco demo class demonstrates the usage of all methods in the deco class. It creates a deco object of integers, performs various enqueue, deco, push, and pop operations, and prints the results. And finally, it demonstrates the isEmpty, size, and peak methods. So, is there anything I want to mention? No, these are my codes, and now demo class codes together. And now I create deco demo class, and we need to write operations. What is its name? Deco. One and same thing for 2, and same thing for 3. And I added system out println things for DQ1, DQ2. Okay, and now we need to write stack operations. This was the queue operations, and now we need to write stack operations like push, pop, etc. And let's go for DQ push 4. I will just copy paste for 5 and 6. And let's copy paste this. What to write inside of this pop? Oof, I made a mistake. Okay, let's fix. I need to write calmer, because calmly. DQ pop, I guess. And it's supposed to pop 6. And I have to write same thing for here, pop, pop. And now we will add other methods. I'm just... By the way, we forgot to add parentheses, so it gives an error. It's gonna ask is empty, false, and size, it's gonna return size 1 and peak 4. Let's test if it works correctly. It's building. Yes, as you can see, my code works perfectly. It gives the results as we were expecting. And our teacher asked to take a look at the slides. By the way, it's pronounced as deck. I was saying DQ, but it's okay. This is a stack type. So add to front item. As you can see, it's as it's a stack type. It requires first in, last out row. Let's fill a row. So here's an example. Again, push item, first step, last out. It's adding from front to the back. Method by creates an instance. Yes, it created an instance. Stock purchase, new stock purchase shares box, price per share, and places it at the back of the DQ because of its stack type. And for lecture 2, we will be looking for this fix. from 46 to 54. Yes, it's linked list. We saw this linked list parts, first node, nodes being connected, and last nodes. What was it? 54. Okay. An outline of link implementation of the ADTQ. It's a private class, constructors and methods, DQ entry, link to next node, and link to previous node. And what's this? Adding to the back of the non-empty DQ after the new node is allocated. It adds to the non-empty DQ. After the addition is complete for B, implementation of add to front and over operation. As you can see, if it's empty, last node equals to new node, else first node set previous node. A deck contains at least 2 entries. It's supposed to have 2 entries after removing the first node and obtaining a reference to DQ's new first entry. It says. And implementation of remove back is an over of O1 operation. So that's all for today. See you.